Today we're going to look at radical equations. Radical equations is an equation that has a radical or a square root inside of it. Normally we'd start off by saying get x alone. This time I'm going to say can you get the radical alone? So I want this whole group right here to be the last thing over there. So let's move the 10, let's move the 4 using inverse operations. Minus 4, and then divide by 10. Okay, so once we're here, now in order to undo the radical, we have to look at the index. We have an index of 4. We're going to raise this whole left side to an exponent of 4, the same as the index. If you do it to one side, make sure you do it to the other. What happens over here? Things cancel, and you're left with just x plus 2. On the right side, 3 times 3 times 3 times 3, 81. And then let's get x alone. Great. Moving on. This radical's already alone. This one's not, but if I move that 2, it wouldn't be alone over here. So what do? Well, we still have to look at the index. I don't have an index, so since I don't, there's a 2. Okay, I'm going to raise both sides of the equation to an exponent of 2. I'm going to raise the whole left side to a 2 and the whole right side to a 2. What happens on the left is things cancel and you're left with just x minus 12. On the right side, we're giving ourselves a distribution problem where we're going to have to multiply these two binomials together. So let's distribute. 2 and 2 is going to give us 4. 2 and that will give us negative 2 radical x. Distribute the negative radical x. And finally, negative, negative, positive. We're left with a radical, x and x squared. And let's simplify things. 4 comes down. Negative 2 is negative 4 radical x. And this is a perfect square, giving us just x. Now I want to get the radical alone. So these 4's have to go, that x has to go. Let's start with the x. Well, that's convenient. Things cancel out. Let's try and move that 4 and that 4 to the other side. So we'll say minus 4, gone. Minus 4, don't forget the negative there, giving us negative 16. Okay, and then divide. Cancel, you're left with 4 equals radical x. Now our index is 2, raise both sides to an exponent of 2, and I'm going to switch sides now. This cancels out, and you're left with just x. On the other side, 16. Great, let's move on. Here I don't have a radical, but I have an exponent that's a fraction. So we have a rational exponent here. I like to just start off and let's turn it into a problem that looks like this one up here. So rewrite 2x plus 1 radical index of 3 equals that. Okay, so get the radical alone, then let's go and get the x alone. So minus 3, 2x plus 1 equals negative 3. I have an index of 3, that means my exponent has to be 3. And I want the whole right side to be raised to the exponent, so I'm going to put it in parentheses. I want to make sure I get that negative as well. Things cancel. 2x plus 1 equals negative, negative, negative is going to be negative. 3 times 3 times 3, 27. And let's move the 1, move the 2, minus, minus. 2x equals negative 28. Divide x equals negative 14. Okay, so normally we'd say, yes, we're done, but we're not. when it comes to equations, when it comes to radicals, we need to check ourselves because sometimes the work that we may have done has been completely correct, but the answers are wrong. We may have something called an extraneous solution. It's the correct wrong answer. So we're going to see if we have a wrong answer here. Let's take these numbers, plug them back in. Now I'm going to take this, I'm going to plug it into this part of the problem because I just don't know how to handle fraction exponents. So let's take this and plug it in right here. We're going to get okay, so let's just simplify. You get negative 28 plus 1, giving us negative 27. And now, is there a number times itself to give us negative 27? Well, 3 times 3 is 9. 9 times 3 is 27. Negative 3 is positive 9 times a negative 3 is a negative 27. So here, what gets repeated 3 times? Negative 3. Plus 3 equals 0. Does negative 3 plus 3 equal 0? Yes, that's good. That means yes, that's the answer. Congratulations, you did everything normal. Next one, though. Let's take that 16 and plug it in there and there. So I'll try and fill it in up here. We're going to say square root 16 minus 12 equals 2 minus square root of 16. 16 minus 12 is going to give us 4 under the square root, which gives us 2. 2 minus, that's going to give us 4. 2 minus 4 gives us negative 2. Does 2 equal negative 2? No, it does not. And that means all this work that we did, it was correct. But that answer is wrong. So we say 16 is something called an extraneous solution. It's wrong. But we did all the work correct. So what's a real answer here? No solution. First one, let's come back. Let's plug 79 in right there. So we're going to get 10 times the 4th root of 79 plus 2 plus 4 equals 34. Running out of room here. 79 and 2 is 81. 4th root, 10 in front, 4 at the end, 34. So what times itself 4 times gives us 81? 3 times 3 times 3 times 3. 3 got repeated, so we're going to say 10 times 3 plus 4 equals 34. 10 and 3 is 30. Does the left side and the right side equal each other? This time they do. That means 79 is the answer. And that is simplifying, or that's solving radical equations.